Hello, good afternoon, and welcome once again to Microsoft Build. We are super excited to be here with you. I am Nagarjuna, a senior product manager at Microsoft.
And I'm Vansh. I'm also a product manager at Microsoft.
Today, we are here to talk to you about the challenges that developers face in the space of testing, and we'll show you how we can help you solve some of those challenges. We'll show you how you can run your functional tests in a more faster manner and with better coverage. And we'll show you how you can ensure the reliability and scalability of your applications using high-scale load testing. And then we'll show you how you can integrate this seamlessly with your developer workflows so that you can ensure continuous validation of your applications. So let's dive in. Over the past few decades, there has been a huge wave of digital transformation, where every company across industries has been leveraging software and digital platforms to serve their customers better. Most forward-thinking business leaders see digital transformation as a means to spark innovation and drive efficiencies. In fact, they see a risk of becoming irrelevant if they don't follow use these digital services to serve their customers. So now, more than ever, there is a need to ensure that the software quality is at its best to ensure the overall service that companies offer to their customers. Now, how should the applications that provide these digital services be, and how should their quality be? These apps serve a global customer base across the world, people who use different operating systems, browsers, different internet connectivity speeds. They use different languages and interact with the apps in different ways. So these apps should cater to all of these users, and for everyone out there, they should work seamlessly. There should not be any glitches. Downtimes, outages, and glitches have resulted in companies seeing losses in revenues, losing the brand reputation that they have, and having dissatisfied customers. So these apps better have reliability and scalability and resilience built into them. And the time from realizing a customer need to actually delivering that value out to the customer helps companies gain competitive advantage and drive growth. So these apps should ensure that companies can iterate faster. And while all of this is happening, delivering features at a rapid pace, they still have to ensure that the quality bar is still high. However, market research shows that companies are not satisfied with their current levels of testing, and they do want to increase their investments across functional and non-functional testing. But why is that so? Lack of time is often cited as a major reason. Companies still use manual testing, and it takes time to run the large, complex test suites and to make sense of the results. And on their journey to automated testing, they see that there is a lack of skill set and a gap in the skill set that their teams possess. And with DevOps practices becoming more common and more developers getting into testing, setting up the infrastructure to run these tests and writing these and executing these complex test suites and making sense of the results is an additional ask of the developers. So it also may lead to dissatisfied developers. And we also see that there is a lack of awareness and availability of the right tool set to perform this automated testing. So how should testing be?
We believe testing tools should empower developers to create high-quality applications. Testing should be easy. In the fast-paced world of web development, applications evolve rapidly. The user experience is constantly changing. Testing for these applications should be easy. Developers should be able to focus on writing the code and growing the application without worrying about tests and the infrastructure required to manage those tests. Testing should be automated. Automation improves efficiency by running tests quickly and repeatedly, and it gives consistent results. It reduces the risk of human error. It also enhances coverage and reliability, as automated tests can be designed to check for scenarios that might get overlooked in manual testing. And it saves time and resources in the long run. It allows developers to focus on more complex tasks and accelerate the overall development process. Testing should be comprehensive. The app should have all kinds of tests written. These can broadly be classified into functional and non-functional tests. Both types of testing are crucial to deliver the quality of the application that not only meets the functional requirements, but also performs well in the real world in terms of security and a good user experience. And finally, testing should be integrated in core workflows. The tests developer writes should work across all environments. They should not need to do anything different to run tests from their local machine or from the CI pipeline. Integration with workflows enable developers to find issues early in the cycle, and it saves time and cost. Today, we are going to talk about these two services. Microsoft Playwright Testing is a service that enables scalable end-to-end testing of modern web apps. It runs tests written using the Playwright framework at scale on the cloud and offers rich reporting. Azure Load Testing Service enables you to run your load test scripts at scale and helps you assess your apps and services under high load. It also helps easily identify performance bottlenecks. Both these services are fully managed, so you don't have to worry about the infrastructure required to maintain and run the tests. They have built-in reporting that gives you rich diagnostics and help you troubleshoot failures fast and easily. They are well integrated into developer workflows. You can use these services from your dev machines or from your CI pipeline seamlessly. Let's talk about Microsoft Playwright Testing. Before we do that, let's take a quick look at Playwright. Playwright is an open source web automation framework developed and maintained by Microsoft. It enables you to write UI tests and test your web application across modern web browsers. It supports multiple languages, so you can choose the language that you're most comfortable with. It has built-in auto-wait and retries that makes it more resilient. It provides full isolation between tests. The execution of one test does not impact the execution of the other. It has parallel browser testing. That means Playwright automatically runs your tests in parallel across multiple browsers and brings down the time that is required to run your test suite. Playwright has powerful built-in tooling. CodeGen is a tool that enables you to record the tests by clicking on the things that you want to test or by replaying the scenarios and generates a test script for it. You can integrate this test script back into your code and run the tests. TraceViewer is another really powerful tool that shows traces collected by Playwright in a very nice UI. It enables you to go backwards and forwards across each step of the tests and collects all the information that is required for troubleshooting. It takes screenshot of every step, and it collects all the browser logs of things that happened during the test. It makes troubleshooting really easy. Microsoft Playwright Testing is a service that extends Playwright open source framework. It enables Playwright tests to be run on the browsers that are hosted on the cloud and offers rich reporting. Imagine a scenario where your team is running tests on every build pipeline or on every PR. While nobody is waiting for these build pipelines, if a PR takes time, it really slows down the development. This service helps expedite those PR runs and gives the results faster. Also, if a developer is writing code and they want to ensure that their changes work across all scenarios, just by adding one browser to the matrix of test increases the size of test suite by a lot. The service can help expedite the execution of these tests and give results faster. The service provides browsers that are hosted on the cloud. That means it can also enable you to choose the operating system where the browsers are hosted. You can test on multiple operating system and browser combinations to ensure your application works across all scenarios and satisfies your users' requirements. The service is fully managed and infrastructure is reliable. This helps increase confidence in testing. And finally, it offers rich reporting and troubleshooting capabilities. It collects the artifacts that are generated by Playwright are published on the service, and you can use them. You can use the service to troubleshoot results easily. We announced the public preview of the service in October last year. Today, you can create a workspace and you can use cloud-hosted browsers provided by the service and use multiple operating system and browser combination to run the tests. Today, we are excited to announce rich reporting and troubleshooting capabilities. It enables you to quickly identify failed and flaky tests, troubleshoot test easily using error messages and other artifacts. It provides in-context trace viewer for exploring Playwright traces for faster debugging, and it is available for both dev inner loop and CI pipelines. Let's now take a look at how the service works. This is a GitHub action workflow that I triggered, and it uses Playwright open source framework. Everything that is happening in the context of the machine that is running the tests. The browsers are open in the machine, the tests are run on these browsers, and the results and artifacts are generated within the machine. The results and artifacts are later stored with the GitHub action summary. You can see it took 20 minutes to finish. Imagine running the same GitHub action workflow multiple times a day. It takes a lot of time. Now, what happens when I run the same GitHub action with the service? You can see it took less than 2 minutes to finish. Now, how does service do that? The service, the client machine now connects to the browsers that are hosted on the service. And since the browsers are not opened in the machine, it can connect to multiple browsers in parallel and bring down the time it requires to finish the test suite. Now, Playwright service can also help you troubleshoot the failures faster. You can see some of the tests have failed. Now, let's see how you can do that. At the end of the execution of this step that runs Playwright test, I get a link. When I click on this link, I am taken to the Playwright service dashboard, and it shows me the tests that need my attention. The view here is filtered by failed and flaky tests. It also contains rich CI information. For example, it has the name of the test run is same as the last commit message. It also has the author of the commit, the branch on which the tests were run, and of course, the pass-fail status of each test. You can see it took less than 2 minutes. And I used 30 workers to run the test. That means 30 tests were run in parallel, and that brought down the time to less than 2 minutes. Now, let's see how you can debug the tests. When I click on any of the tests here, it gives me all the information that I need to troubleshoot. It has error logs. You can see here it looks like it was expecting to find some text which was not visible on the page, and that caused the test to fail. It also contains the artifacts that I enabled in my Playwright config, which is screenshot and videos. You can see this is a screenshot of what happened during the test, and this is the video capture of the test. I can play the video inline and see what happened. The service dashboard also hosts the trace viewer. This is the same trace viewer that I mentioned earlier, which is a really powerful tool that makes troubleshooting easy. I can click on this button and see the trace viewer. I can hover over the timeline of the test and see what happened during each step. I can also click on any of the step, and it gives me the snapshot of what happened there. It also contains logs of all the things that happened in the browser. I can look at the network, I can look at console, I can look at the errors, and so on. Trace viewer makes troubleshooting really easy and fast. Let's now go back to the dashboard and see what else is there. The list of tests that I have can be filtered using multiple filters. I can filter using project. This is the Playwright project which I have configured in my Playwright configuration, and the job. This is the job that this is the CI job on which the tests were run. And of course, there is filtering based on status. The Playwright service dashboard also integrates really well with your code repo. You can click on the link here, which is the link of the commit ID, and see the changes that you made that triggered this test run and caused the test to fail. It seamlessly brings you to the code base where the code was written from the dashboard where you are troubleshooting the tests. You can go to the homepage of the workspace and see the historical data of what happened about the test runs in the workspace. You can go back in time and see when the test run started to fail and go to that particular test run and troubleshoot failures. So this is really great. The service can bring down the time that it takes to run your tests and gives you rich troubleshooting capabilities. Now let's see how you can integrate the service with your Playwright project. So this is a Playwright project that uses open source framework, and I'm testing an e-commerce application here. Let's try to run these tests using the open source framework. When I run this command, you can see it is running a bunch of tests using 4 workers. Playwright automatically spins up multiple browsers and runs tests in parallel. But the problem here is my machine cannot scale beyond 4 workers because the capacity of the machine is limited. If I go beyond 4 workers, then the tests will start to become flaky. Now I'll cancel this run, and I will integrate this project with the service. To do that, the first thing I need to do is go to playwright.microsoft.com and sign in using my Microsoft credentials. Here I need to create a workspace. A workspace is an instance that is created for you that hosts browser, and you can run your tests there. So I can do that by clicking on the button here. It asks me some information. So I'll give this workspace a name. Then I need to choose the Azure subscription where I'm creating the workspace, and the region. This is the Azure region where workspace will be created, and all the data that belongs to this workspace will be stored, including the test reports and artifacts. As soon as I click the button, the workspace will be created for me. Let's go to a workspace that is already created and see the next things that we need to do. The home page of workspace gives a list of steps that I need to perform to integrate my test suite with the service. The first thing I need to do is I need to create a new file at the same location as my Playwright config file and copy some content there. So I'll open this link and copy the contents of this file, go back to my project, and create a new file here. The file is created, and I will paste the contents of the file here. I'll save this file. We'll come back to this file and see what is happening. But for now, let's look at the next steps. Next, I need to set up some environment variables. The first one is access token. Access token is required to authenticate the machine where the tests are being run with the service. And then the next one is the region endpoint. Region endpoint is the endpoint that my client machine needs to connect to authenticate itself and request for browsers. In my setup here, I've already configured these 2 variables in the .env file. Now let's look at the file that I just created. This file extends my existing Playwright config and adds the capability to connect to the browsers on the service. It does that by using this function called connect options that takes the environment variables that we just set as inputs. The Playwright service URL is the endpoint which will give me the browsers, and access token is the token that I will use to that is required to authenticate the client. I can also choose the operating system by specifying it here. This operating system could be different from the operating system that I'm using in my client machine, which is running the tests. In this case, I'm using Linux. Now, this was about the cloud-hosted browsers and testing across multiple operating system and browser combinations. To configure reporting, which is publishing of test results back to the service, I need to install an npm package. I've already installed the package. The next thing I need to do is add the reporter in my Playwright config file. This is same as adding any other reporter in Playwright. So I'll add this reporter here, save this file, and we are ready to go. The command that I need to run here is this. This is the usual Playwright command, and I'm using the configuration file that I just created, which is extending the config file and enabling the client to connect to the browsers, and I'm specifying number of workers. Number of workers means the number of parallel browsers my client is going to connect to. In this case, I'm using 30 browsers. Let's see what happens when I press enter. You can see my client is now connecting to 30 browsers in parallel and running the tests there parallelly. And just look at it, how fast it goes. While this happens, let's look at what is happening in the background. When the tests are run using the open source framework, not with the service, this is what is happening. When the npx playwright test command is triggered from the client machine or a dev workspace, Playwright test runner spins up number of workers. These workers are lightweight processes, and each worker connects to a browser which consumes a CPU core. You can see the bottleneck here. Everything is happening with the constant. Everything is happening in the context of the local machine, and the CPU cores are limited. So only a few number of browsers can be spinned up parallelly. When you run the same set of tests on the service, nothing changes. The environment remains the same. When the npx playwright test command is triggered and the number of workers are specified, playwright test runner spins up those many number of workers. These workers are again lightweight processes, so they don't consume a lot of resources, but each worker now connects to the browser that is hosted on the service. So the CPU core that you saw in the previous diagram is now the services core that is being used. So the client can connect to multiple browsers and run the tests parallelly. Once the tests are run, the local machine can also publish the results back to the service, and those results can be viewed in the dashboard. Let's go back to the run and see what happened there. It's still running. There were some tests that I had enabled retries for, so those are being retried. You can see it finished in less than 2 minutes. With performance gains like this, teams can deliver features at a faster velocity and more confidently. So we saw how you can integrate service with your Playwright project and run tests faster. We announced reporting feature of Playwright that enables you to publish the test results and see the results on the dashboard. If you are interested in trying out the feature and give us your valuable feedback, please sign up on this link. I will now hand it over to Nag to talk about load testing.
Wasn't that a cool demo? 20 minutes to 2 minutes and wider coverage of test suites. Let's switch to performance testing now. Azure Load Testing is a fully managed load testing service that enables developers and testers to easily generate high-scale load and also easily identify performance bottlenecks. Now let's understand this a bit more in detail by thinking of the typical journey of a performance test. Let's say you want to test the user flow to your e-commerce application, and you want to see how the application performs when there is high-scale load. The first thing that you do is create a test script for your scenario. So if you are already using some popular open source frameworks like JMeter, you can get those scripts as is and run them seamlessly on Azure Load Testing. Or if you are new to performance testing and you are not familiar with any tools, you can get started right from the interface of this service in Azure portal. You can configure your requests in the portal, and you can set up your test scenario. Once you have your test scenario set up in the form of a test script or using the portal, the next thing that you would think of is how do you generate the high-scale load that you want to test your application against. So you might be thinking of spinning up some infrastructure, maybe some VMs, orchestrating them, collecting data from them, and making sense of that data. So all of that is taken care of by the service again. The service takes care of spinning up the infrastructure, pulling data from all of these machines, and also creating rich visualizations for you. So all you have to do is analyze and make sense of that data. And the even cooler part is, now if you analyze the client-side metrics and you see that there is some performance dip or something unexpected happening, you want to go troubleshoot that. So you will look at what is happening on the server side of things, and you will look at the resources that are running your app. So the service also brings metrics from your server-side components along with the client-side metrics so that you can easily troubleshoot. Now, if you have done this once, and you want to ensure that each time you push a new feature or an update, your performance remains as is, you would want to integrate it into developer workflows. So the service, again, helps you with that. You can integrate your load tests into your CD workflows and run them on a continuous basis for continuous validation. We are excited to have a bunch of announcements today, announcing the general availability of multi-region load tests. So with this feature, you can generate load from multiple regions simultaneously in a single test run. So if you have a global audience that are using your applications, you can generate load to simulate real-life traffic patterns and to better test your network architecture and load balancing components. The feature is out there now, and you can go try it out. And we are now coming up with the better together story. You would have heard this in some of the earlier sessions on app service. So you can now test your app service web apps from within the interface of app service. You can run load tests, see the history of your load tests there, see the trends of performance of the web app, all within the interface of app service. Again, this integration is generally available. You can go try it out now. We are extending this goodness to Azure Functions as well. You can do the same thing with Azure Functions web app. This is right now in preview. Please try it out and share your feedback. And we are making this better together story even better. You would have heard of the announcements about the flex consumption plan in functions. Now load testing works seamlessly with flex consumption. If you have a bunch of options that you are considering, you just tell us the options. The service runs load tests on the combination and gives you the useful metrics for you to take a decision easily as to which combination you should go with. This is coming soon, so stay tuned. And we are also announcing support for another test framework. Till now, Azure Load Testing supports Apache JMeter. We have high fidelity support for Apache JMeter, and now we are extending the same support for Locust as well. Locust is a Python-based open source framework for load testing. The goodness with Locust is that you can write Python code to create test script, as opposed to creating the test scripts in a GUI interface as with some other tools. So if you are someone who loves writing code, you can just write Python code and get that Python code to Azure Load Testing and get all of the benefits of the managed service that we just talked about. This is currently in preview by invite. You see the link up there. So if you are interested, go sign up and please share your feedback. Now let's see some of these in action through this demo. -D. So to get started with Azure Load Testing, you start by creating an Azure Load Testing resource. You just give it a name, choose the resource group, choose the region, and you land here. So this is the landing page of an Azure Load Testing resource. So now with this, you think of this as the workspace or the hub of all of your performance testing activity. You don't have to worry about where your previous test scripts were, where the results were, how were the results the last time you ran the test, what happened before. You don't have to worry about all of that. You come here, you see the list of tests, and you can run each test any number of times. You see the test runs, you see the test results. All of that is available in this resource. Now, if you want to get started by creating a test, we talked about 2 ways in which you can do that. These are the 2 ways. So you can add HTTP requests and get started right from this interface. So you can just give the URL, the load that you want to generate, the time for which you want to run the tests, and get started. This is if you have a single URL, which is not usually the case. So if you have some advanced scenario, you can enable these advanced settings. Go to the test plan tab. Here you can add multiple requests. You can choose the type of method, get, post, patch. And if you have some headers, you can pass those. If you want to correlate the request, like user picking a product, adding it to the cart, so all of those correlations, you can do it here. So through this interface, you can set up your test scenario right in the interface of this service. This is one way of going about it. The other way is where we have a test script and we want to use that. So let's say now I have a podcast web application where people can come there, search for podcasts, and see their subscriptions. Now I have a Locust script for that. So this is a simple Locust script where I have some Python code of a user going to the home page and a discover page and subscriptions page. So now I can just upload the script and get started. So I can get started by giving a name to this. Let me call it build demo. And then here I choose my framework. So like I mentioned, JMeter and locust, you can choose either of these, whichever suits for you, for your scenario. Here I'm going to go with locust and select my test script. So here I have a simple test script, but if you have some configuration files along with it, or if you have some data that you want to pass as a CSV file, or if you are using some plugins, you can do that. So any of the files that you want to upload along with the test script, you can do that here. Now you can also parameterize your tests. So each time you run the test, you can change the values of the parameters you provide. Here are some standard locust variables that I can later configure in the load tab. And if your test uses some secrets or certificates, you can put those in Key Vault and give the Key Vault reference here. The service securely pulls them for you and passes those along with your requests. So that is taken care of by the service in a secure manner. Now let's go to the load tab and see the high-scale load thing that I've been talking about. So I was telling that we take care of, the service takes care of spinning up the infrastructure. So these are the engine instances that you can choose, and the service spins those up for you. So let's say you want to generate a load of 1,000 users. So you can say how much load you want to generate from one engine, and then how many such engines you want. So you can usually go up to 250 virtual users from one engine. So if you want 1,000 concurrent virtual users, you can put 250 here and choose 4 engines. Now I want 200. I'll just put 20 here and say I need 10 engine instances. That's it. I can ensure that the load that I want gets generated. Now here I specify the duration for which I want to run the test. This is a demo, so I'll just maybe run it for 5 minutes. But with the service, you can run tests for up to 24 hours. So you can also do all of your soak test scenarios. So, and coming back to the scale, the service supports up to 400 engine instances, and with the usual number of 250 per engine, so you can go up to 100,000 concurrent users in a single test. So that's the amount of load that you can generate. And when such load gets generated, it's petabytes and gigabytes of data that gets generated, so that is also taken care of by the service. So the next input that I have to give is the spawn rate or the ramp up time, so how fast the users get added. I'm giving that, and I'm also giving the endpoint to test. So I can give this here, or I can specify it in the locust script as well. I'm choosing the option of providing the endpoint here. So this is a public endpoint, which is accessible from the engines, so I don't have to worry about anything. But let's say you have a private endpoint, maybe your pre-prod environment or your UAT environment. These are not accessible publicly. Maybe they are accessible from within a virtual network, so you can set that up here. So you can test private endpoints as well. You just choose the private option, give the virtual network subnet, and the load gets generated from within the subnet. Now let's see the other announcement that we made today, multi-region load test. Now all this load that I configured here from the 10 engines is coming from only the region of the resource East US, I guess. But now I want to simulate a global load. So I just go about adding the regions that I'm interested in. I'll choose one from Asia, Australia, maybe Europe, and yeah, that's it. So the load that I have here, the 10 engines that get distributed across all of these regions, if I want to tweak and get different amounts of load from different regions, I can do that here, and that's all. I'm now able to generate load from multiple regions. And now once the test is run, I want to evaluate whether my performance is good or not. So I can set that up as well here. I can set up my pass-fail criteria here. Let's say I want the response time to be less than 10 seconds. So I can say that anything 90th percentile response time greater than 10 seconds is a failure for me. So I can define my failure criteria here. So at the end of the test, you will get to know whether the app is meeting your performance expectations or not. Now, moving on to one more cool thing, which is the server-side monitoring that I talked about. So if you have your apps hosted on Azure, you can add your Azure resources for monitoring. So you can just select the resource group. Here, my podcast app resources or in this resource group, I just select that. And here I have all of these resources. So I'm picking the ones that are relevant to my test scenario. I'm selecting an app service. I'm selecting an app insights, app service plan, and I also have a SQL DB. Yeah, here it goes. So I'm selecting all of these for monitoring. So what happens is these get monitored during the test run, and then you see the metrics of these along with the client-side metrics. So that's it. We did a bunch of things, but if you just think of it, we started with the test script that I had in Locust. I configured the load that I wanted, and I selected the components that I want to monitor. So within a few clicks and a few steps, I set up the high-scale load, and I have set up monitoring as well. So we can go ahead and create the test. The test gets created, the script gets uploaded, and the test run starts. I would have loved to show the live dashboard with the metrics coming up, but in the interest of time, I have a run that I previously did yesterday. So yeah, once the test run completes, this is how the dashboard looks like. So you get to see a bunch of statistics about performance, like how was the response time, how was the error percentage, what was the throughput, and you can drill down into the multiple requests that we had. We had a discover page, subscriptions page, so I can go see the statistics across all of these individual pages. And because it was a multi-region load test, I also get a comparison of performance across different regions. So here I can see if my global audience is everyone experiencing the same performance, or are there differences? Now I can, yeah, we set up a test criteria, right? So it's not meeting. So my test case was a failed case. It's not meeting my expectations. I can also go about viewing the client-side metrics. So this graph shows how the load was ramping up. And in correlation with this, you can see how the response time was, how the throughput was, were there any errors, all of that. Now, the server-side resources also get monitored. So I see that there are some errors here. And the response time is also not that great, around 25 seconds. So I want to go see what's happening. So here are the metrics from the server-side resources. So I can see that as the load is ramping up, the CPU consumption of my app service is going up, and the memory consumption is almost close to 60. It's not that bad, so we do not see much of errors, but the performance is not that great. So one thing that I could think of is maybe choosing a higher SKU for my app service. So I did that and rerun the test, and this was what happened. So the response time came down from almost 20 seconds to 9 seconds. So just by using the dashboard, I could correlate what's happening on the client side with what's happening on the server side, identify the bottleneck, fix it, and then rerun to see if it actually fixed the problem. So again, you can also compare these two runs using this compare option and see what exactly changed, or how the load was, and throughout the load test time, where it was going better, and all of that. And for the components that you selected, by default, you get a bunch of metrics like the ones that you see here. But if you are interested in seeing some other metrics, you can go customize that as well. So you can customize the metrics from here. So let's say you have been doing this for a while, and you have a bunch of runs over the past few days or months. You come to the resource, go to the test runs tab, and go to the trends. You have a nice dashboard showing how your performance is trending. If you were satisfied with the performance, you can choose that as a baseline, the pink line that you see here, and you get a comparison of how your current performance is as against your baseline that you set. And if you want to debug a run, let's say there is high response time here. I want to know what happened in detail here. I can just go to the table view, click on that run, and open the full-blown dashboard that we just saw. So all of the generation of high-scale load and the monitoring is taken care of by the service. Just switching back to see what's actually happening behind the scenes. So this is a high-level architecture diagram of what's going on as the test was running. So the test engines got spun up as per the input that was provided. The JMeter or Locust script was run on all of these engines. the server-side components or resources that you chose were monitored. So what's happening is basically the metrics of these resources from Azure Monitor are also being pulled into the same dashboard. So the metrics from the test engines and the metrics from Azure Monitor are both coming into the same dashboard, and that's where you see the integrated dashboard. Now, you have done a one-time testing and improvement, and you would want to do that each time in your developer workflows. And Vansh is going to talk about how you can do that.
Those were some really cool dashboards. Now let's look at how you can use the service or combination of both the services in your CI workflows. In your deployment pipelines, after you do the build and deploy of your application, you can use Microsoft Playwright Testing to run your UI tests fast, get the reports in form of the Playwright's artifacts that we just saw, and you can use Azure Load Testing after the app is deployed and your UI tests have succeeded to make sure that your app meets all the performance benchmarks. This is a GitHub Action workflow that does exactly the same thing. The first step here provisions the application. Then we do UI test using Playwright open source framework and the service, and you can see how fast it runs all the tests. And after that, we do load testing on multiple parts of the application to make sure that it is always performant. This is a GitHub Action workflow that simulates what we saw just now in the previous snapshot. This is the step that runs Playwright test, and it depends on the provision step. This sets up all the environment variables that are required to run the test. For example, the username, password, and the URLs that are required. And when you see the steps that are required to run Playwright tests, you can see there is one step that installs the dependencies, and the second one is to run the test. The step that runs the test sets up environment variables, which these are the same environment variables that we saw in the demo. Playwright service access token is required to connect to the service or authenticate to the service. URL is the endpoint where the service is hosted, and the run ID. Run ID is a unique run ID that helps the dashboard differentiate between multiple test runs. And then the command is executed. You can see it's really simple. All the steps that we performed to integrate the local setup with the service is same as what we do in the CI pipeline. Let's also look at how you integrate load test. Load test has a GitHub Action workflow that you can use. It takes the config file, as a parameter. This contains the information, or this contains the configuration that Nag just demoed while setting up the load test. And you need to specify the name of the resource and the resource group. And that is all. The integration of these two services with CI workflows is really simple, and you can use them in your continuous pipelines to make sure that you always deliver the best possible quality of your application. Now, to quickly summarize what we saw today, we saw the importance of automation testing and some challenges associated with it. We talked about two services, Microsoft Playwright Testing that enables you to run Playwright tests at scale and gives you a rich dashboard that you can use for troubleshooting. We saw Azure Load Testing, a service that helps you run your load test scripts at scale and identify performance bottlenecks. And then we saw how you can use the two services together in a pipeline to always make sure that your applications are of the best possible quality. If you are interested to know more about these services, you can go to these links and get started. We are here. The team that has built the two services is here. So please feel free to reach out to us if you have any questions. Thank you.
Thank you.